Welcome once again, my friends. Today we are going to see this workpiece. You see, this is turning operation. We are going to design this workpiece in SolidWorks, and finally we will use CAD CAM, SolidWorks CAM to make operation on this workpiece. So I hope you enjoy. We are going to see about turning operation in SolidWorks. Subscribe to our channel to get more videos. So let's start. Open new part. Okay. Front plane, a sketch. Choose center line. Draw center line passing through origin. Okay. Okay. Choose line. Start from origin. Like this. Like this one. Okay. 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 You see, so assign dimension. Give this one 150 millimeter. Assign this 15 millimeter. Okay. Give this side 15. So give this side also 15. Okay. Give this side 25. Okay. Give this side 30 millimeter. Okay. Assign this distance. Give this distance 20. Okay. Give this also 25. Give this one 40 millimeter. Okay. Give this side 30 millimeter. Give this, edit this, give 25. Okay. This give 30. So this is fully defined. Go to features, revolve boss base. You see, say okay. Assign this chamfer, this fillet, give 3 radius. Okay. Say okay. Assign this chamfer, give it 4 distance. Okay. Assign this on another side chamfer of 4 distance. Okay. Assign this one chamfer of 5. Okay. Assign this fillet 5. Okay. Okay. Say okay. So you see, my workpiece is now created. Make white plane. Okay. Go to appearance, assign material, metals, aluminum, add cast aluminum. Okay. Set cast aluminum. Okay. Save as turning. operation. Okay, save. So this is workerpiece is created. Now we are going to insert lens machine for turning operation. So go to SolidWorks, come define machine, you see, then you see this is millimetric. This is millimetric, it means it is milling operation, reserved for milling operation. Then select this turn single turret metric, then choose medium duty and select. You see the machine has changed, it is turning single turret. Okay, okay, this is turning single turret. You see this, all operation you are going to perform on this workerpiece are displayed in this manager tree, this side manager tree. Okay, so coordinate, define coordinates. You see it is going from Z axis to X axis. It is going in Z axis and Y and X axis. You see this is coordinates of your machine movement. Say okay, go to stock manager. Stock manager, it is to define the size and length of your workerpiece, of your full workerpiece. Okay, so this is tool material. Okay, this is material and tool number. Okay, so in stock manager you increase the size or tolerance for which cutting tool is starting for the operation. So you see this, I can increase like this. You see, look at here how it is increasing. While you are fixing your workerpiece in chuck, you have to remain in the some distance where the chuck has to be held. So this is why we increase this in this direction. So look in forward, so you have to add 2 millimeter as the tolerance for starting turning operation on your workerpiece. Add 2 only, 2 millimeter. Let's check here. So you see it is increasing in diameter. So here also add only 2 millimeter as a tolerance. Okay, so let's check. So 50, let's decrease 50 and give 40. Okay, check stock manager. This is 40, this is 40 in chuck hold, and 2 in forward directions, 2 in terms of diameter. This is okay. So friends, go to setup, turn setup. You see you have to use this coordinates in turning operation. Okay, no problem. So go to extract machinable features. You see, so you have generated some turning operation that your machine is going to perform. So this is face, rough, this is rough, finish, this is groove, rectangular, and this is cut off. This cut off, you see, while machine complete the turning operation, it has to cut out the workerpiece from a chuck. You see, cut off. Then you go to generate operation plan. You see, this manager tree shows all operations that machine performed to complete the task. You see, this is the rough. You see, this is the rough operation plan, and then generate tool pass. Okay, This is very important. Tool paths, you see how tool comes from and moves back in safe position. You see, this is the movement of tool for first rough one, you see, and this is the movement of tool for finishing rough finish. Okay, this is good. This is turning operation for using tool 1, you see. This is the turning operation, it's tool paths, you see. Very good. Okay, this is finish, rough finish. Okay, this is groove. This is grooving operation. Tool paths were in grooving operation, you see. This is grooving finish. Okay, then this is cut off, you see. So my machine is going to use this number of tools. We have tool 1, we have tool T01, we have T03, we have T01 for diamond. We have these all tools are diamond, you see. We have T01, we have T05 for groove tool, we have T07 groove tool, and we have 209 cut-off tool. So you see, this is how my machine is going to perform this task. So then simulate, go to simulate tool path, you see. So now my workpiece is fixed in a chuck, you see. Is fixed in a chuck. Then you can add the lines like this, you see. My workpiece is fixed on a chuck, so this is good. So if I cut off my workpiece, it is not going to damage my chuck. So you see, it's very important to check this one. So go to shade display to get round bar. This is my round bar fixed in workpiece, in drill chuck, in length chuck. You see, this is good. So then go to run machine. You see, this is run machine. Okay, you can decrease speed. You see, you can decrease speed and go to run machine. You see, this is how workpiece is going to be turned by different operation. You see how machine is changing the tool. You see, this is how machine is changing the tool according to the operation is going to be performed. Very nice. This is CAD CAM, SolidWorks CAM for turning operation. You see, this is good. You see how tool moves back and forward according to the tool paths we have set in our machine. You see, for all operations from the start up to the end. You see how turning operation is being done by different number of tools we have seen in the machine. So this is turning operation by using SolidWorks. Okay, you see how the fillet is being cut. You see, this is good. So wait the machine for finishing its operations according to the setting. So you see, you can increase speed. You see, increase speed, and the machine is changing the tool according to the operation. So you see, this is turning operation. This is very nice. You see, this is good. This is good. You see how the chamfer is being formed according to the tool. You see, very nice. So you see, that is the cut-off. Look how the tool is changed. You see, finishing tool. You see, look how it is going to bring grooving tool. So you see, look how it brings grooving tool. Very nice. You see, that is grooving tool. You see, that is grooving tool. In grooving tool, machine goes slowly, so you can increase speed. You can increase speed because in grooving machine goes slowly, very slowly. The speed is slow in grooving, so you can increase speed. You see, look how grooving is performing. Very nice. This is SolidWorks cam and turning operation. See, don't forget to subscribe to our channel to get more videos, and share and comment on your videos is very useful for us. So you see how grooving is performing. Very nice. So you see, our machine have performed turning. This is fillet, this is chamfer, this is another chamfer, is now performing grooving operation. You see, this is also fillet. Very nice. You see how grooving is performed by using turning operations. You see, that is how grooving is performed. So in a grooving operation, the speed of cutting tool is decreased. That's why it takes time. That's how it takes time. Okay, it finished. So friends, this is how the turning operation is done by using SolidWorks cam. So next time we will see how to generate NC code by using SolidWorks cam. So I hope you have enjoyed the video. Subscribe to our channel to get more videos. My friends, thank you.